What's going on, guys? So I hope you've been enjoying these guest creators that I've been having on, and today we have a special guest, Ania, and she's going to build the game Minesweeper in JavaScript. So she actually does a lot of games. If you check her channel out, she does like Tetris and Candy Crush type games. She also works with, in addition to vanilla JavaScript, React and React Native, and she's a really cool editing and presentation style, so it's really unique. And the game she's going to create today is Minesweeper, and she's going to focus a lot on recursion. So there are some advanced elements in this project that I think a lot of you guys will enjoy. But her channel is in the description along with the code for this project. So let's go ahead and get started.
Hey everyone, super excited to be here today on Brad's channel. Brad has been an incredible source of inspiration for me since starting my own YouTube channel, so I'm so honored to be here today with all of you. So I decided today to make our own version of Minesweeper, not only because I'm super into retro games, but because we get to grips with one major theme: recursion. But what is recursion? Let's switch over to children's mode to explain. Hey Coda Cat. How's it going?
Oh, hey, Anya. All good here. How's your video doing?
Very well, thanks. Just teaching these guys some computer science. I think the audience has a question for you.
What is recursion?
Well, in the least amount of words, recursion is a function that calls itself until it can't anymore.
That calls itself?
That's right.
You mean a little bit like this. Here we have an ice cream, but I don't like this ice cream. It's too small. In fact, I know the exact ice cream that I want. It is blue with a flower on it. This is my base case. Now I can apply a function to this to check for my ice cream in, say, the next 5 surrounding shops. If this ice cream is not the exact one I want, we will keep going to the recursive case of the function, meaning we will check the 5 stores of those 5 stores we just checked until we find my ice cream and I stop throwing a tantrum. So that was a simple explanation of what recursion was all about, but let's have a look at it in code. Here is how we will be using recursion in order to check neighbouring squares of any square we click in our Minesweeper game. What is happening here is when we click on a square, we have many arguments that can make us break this recursion, as you can see here by the returns. If none of these are met, we then go to another function called checkSquare, where we check our neighbouring squares on the board. Don't worry if that was a lot for you to take in. It should be. This stuff is pretty hard when you get started, but we're going to be going through it step by step until we get our finished game. For those of you who don't know how to play Minesweeper, it's a simple game where you have to find all the bombs on your grid. If you click a square with a bomb, your game is over. However, if you click an empty square, 2 things will happen. If the square you click on is next to any bombs, so if any square around it, the 8 squares around it have a bomb, that square will show you the total number of bombs surrounding you. If the square you click on is not a bomb and is not next to any bombs, so it's just an empty square, we need to go around and clear all the little squares around it until we hit some numbers. Recursion. You win by placing little flags on all the little squares that you suspect have a bomb in them. We will also be using the popular methods of fill and array. These JavaScript methods are super popular, so it's great that we're going to get to know them, along with many, many others. As always, please do finish your finished games of Minesweeper with me. I'd love to see how you've made them, taken them your own. We're going to be focusing on the logic, so the styling is going to be totally up to you. Please do reach out to me on Twitter, YouTube, whatever. I'll put my socials at the end. Okay, let's do this. Minesweeper. Thank you so much, Traversy Media, for having me. As always, let's make sure we have our project set up correctly with our script tag linking our JavaScript file to our HTML file using the JavaScript file's relative path. We do the same for our CSS file using the link tag like this. As we have both files in the root of our project, the relative path is simply each file's name followed by their file extension. If you are not sure what any of this means, I've done a simple explainer video on how to set up your project in your code editor, along with preferences that I choose for writing projects. Definitely check this out if you haven't already. Now I'm going to start by adding a div with a class of grid. This is where all of my game is going to visually populate, which is pretty cool. We're going to be appending divs into this div using our JavaScript. I'll show you how to do that a little bit later. Now let's style this div up so we can see what is going on. Flip over to your style sheet and add the following. So I have predefined that my Minesweeper grid is going to be 10 by 10 squares big, and each square is going to be 40 pixels height and width. Let's account for that in our grid. So 10 times 40 is 400 pixels. Let's assign that to our height and width like this. Now we also need to use display flex to make sure our squares appear inline, not stacked over each other like the default arrangement of divs. We also need to do one more thing, and that is make them wrap over each other so that they fit in the grid we have just made. And once they do not, they wrap over each other like a snake. Let's also give it a background color of gray for now so we can see what we are doing. While we are here, I'm going to actually also style any div that goes inside my grid. So the div with the class of grid. This is how we tell our CSS file to do this. By writing .grid and then div after it like this, I am saying I only want to style the divs inside this grid div. All other divs will be unaffected by this. I'm going to give each div a height and a width of 40 pixels. These are now going to be our squares that we discussed earlier. Let's see how this all looks so far by navigating to the index.html file and left-clicking it. We select Open in Browser from the drop-down. This will essentially open our path in our default browser. And there we have it. We can see a grey grid as we intended. I'm just going to make it a little bigger so we can see what's going on. Now I'm going to inspect the page. Using the left click again, we select Inspect from the drop-down. Once we have this, we can now inspect all the elements. So if we navigate over to the grid, you will see we are picking up the div with the class of grid. At the moment, it's just one grey square we have, as we haven't added any of the divs inside to it. Okay, now great, let's flip back to our project. We need to start picking out these elements so our JavaScript can talk to them. Flip over to your app.js file. Now, the first thing we're going to do is add a DOM EventListener to our file. We do so by getting the document and adding an event listener, then passing through DOM content loaded like this. All our code will now be written in between these curly braces and parentheses from now on. We are doing this so that we can make sure all of our HTML file is loaded before reading this JavaScript code. Some people like to do this by placing the script tag at the bottom of their HTML files, so after all their HTML code, but this is my preference as I feel it's more foolproof. Both ways are really correct. Now we have that, let's pick out our grid. Using constants, as this will not change, I use document and attach the inbuilt JavaScript method query selector to it. In it, I pass through the class name of grid. Please note, I am using a dot to tell the JavaScript I'm looking for a class name. Now, the JavaScript knows to select the div with the class name of grid from my HTML document and call it grid, so that we can use it later in our JavaScript as grid. Let's also tell our JavaScript that our grid is going to be 10 squares width. We will be using this variable a lot in the walkthrough. We are now going to write a function to create the board. I have used this quite a few times in my other grid-based game walkthroughs, so if you're familiar with it, this is great practice. Let's call the function createBoard. Now, the first thing I'm going to do is use a for loop to loop over a block of code, executing it as many times as I want. As I want to create 100 squares to make up my grid game, I'm going to make this loop 100 times. So as long as I is smaller than 100, so width multiplied by width gives us 100, I want this block of code to keep repeating itself incrementally by 1 each time. So repeat itself from 0 to 99, going up by 1 each time, indicated by this I and the increment operator or ++. As you may or may not know, when we count times in an array, we always start with the 0 index. So even though this is going to keep going until it hits 99, it will execute the code 100 times. So what do we want to do 100 times? Well, we want 100 squares, right? Using the constant of square, I'm going to use document and an inbuilt method called createElement to create 100 divs in my HTML document. Every time I create one square, I also want to give it a unique ID. I do this by grabbing the square I just created and using the inbuilt method of setAttribute, passing through the string of ID, indicated by the 2 quote marks, that's a string, and I, which is the number from 0 to 99. After I've created a square and given it an ID so I can keep track of it, I also now need to put it in my grid. I do this by grabbing the grid constant and using the inbuilt method of appendChild to pass through the square as a parameter. Now I'm going to do one last thing. First, let's create an empty array called squares. So let squares equals square brackets. Now let's use this array squares and push the square we have just created into it. Okay, great. Now let's invoke this function to make this happen 100 times. Let's save this file, refresh our browser, and great. If I now inspect the page, you will see my grey grid is filled with lots of little square divs, 100 of them to be exact, each with their own unique ID from 0 to 99. Okay, let's flip back now. Now that we have our grid, we need to randomly place bombs all over it. Let's do that in our createBoard function. So I'm going to use a constant and choose to call it bomb array. At the top of my file, I'm going to globally decide what my bomb count for the game is going to be. Let's go with 20. We can always change this later or use this variable to, level up if we choose to make more levels to the game, adding more bombs. Okay, so using the input method of array, I'm going to pass through the bomb amount like this. What we are doing here is making an array of 20 indexes. Now, using the inbuilt method of fill, I'm going to fill each index with a string of bomb. Let's use the same logic to make an empty array now for the remaining squares we need to account for. So array and pass through width multiplied by width minus the bomb amount. This gives us number 80, right? Now we want to fill these 80 indexes with the string of, let's say, valid, as these are valid moves. Now, before moving on, let's see what's happening using our console log. Let's console log out these 2 newly formed arrays. So console log bombs array and console log empty array. Save the file, flip over to our browser, and great, you will see in the console that we have 2 arrays, one of 20 bombs and one of 80 valids. Let's carry on. We now need to do 2 things. Join the 2 together and mix and model all of them up randomly. Let's store this as a new array called gamesArray. We will do so by taking the empty array and using an inbuilt method of concat to pass through the bombs array. This will result in 2 arrays being joined. Once again, let's console log this array to C. You can technically join the empty array to the bombs array too. It makes no difference for us. The order of the words does not count for us at the moment. Okay, great. We can see here that our third array is the 2 arrays joined together in order. Now we need to make one final array. I'm going to call it shuffled array. This is where we shuffle the words about. We do so by getting our newly created games array, then adding the inbuilt method of sort to it. Now, using an arrow function, we write this and invoke the inbuilt method of mathRandom and minus 0.5. Let's console log this to see if it has worked. Let's save this file, and great, you will see that with each page refresh, we are getting a new randomly shuffled array. Now let's flip back to our JavaScript file. I'm just going to do some spring cleaning and get rid of these console logs first before we move on. So delete. Now that we have our shuffled array, let's get to adding these names as classes to our squares. So how do we do this though? How do we basically get the shuffled array and the squares array and add the words to the class names of the squares array? Well, we go back to our for loop. Right here, under where we give the square a unique ID, we are also going to give it a class name. So let's grab the square, use the classless method and the add method to add the class name of whichever word corresponds to whichever index we are looping over in our squares array. So, for example, if we are looping over this code and have just created a square with an index of 0, we then want to go to our shuffled array, find the index of 0 in that, and bring back the word that has an index of 0. We then do the same for the first index, the second index, and so on until we go through all 100. I know it can be a bit hard to visualize, so let's add some styling for us to see what is happening and if it has worked. Let's flip back to our CSS file. In here, let's add some color to the class name of BOM. Let's go with orange as it will stand out over the gray. Make sure to put it after the gray here as well in our CSS file. So BOM, and then background color of orange, and save. Let's bring up our browser and refresh. And great, you will see that it's working. We are adding class names to the squares. Let's refresh again and again to see if it's generating randomly. And great, let's move on. It is now time to add numbers to the neighboring squares of the BOMs. So as you know in Minesweeper, if a square has a BOM in any of the squares to its left, right, south, north, but also southwest, northwest, southeast, and northeast square, we total that number up and display it to the user. This means we have to check every squares surrounding 8 squares for BOMs and total up the BOMs in the neighboring 8 squares. We will do this again using a for loop. Make sure you are still in the createBoard function. Okay, now let's loop over the length of the squares array. So our squares array and then the input method of length to give us the number 100. Once again, we want to execute a block of code 100 times. Now we also need to account for one more thing, and that is if the square we are checking the neighbors of is in the left-hand side or the right-hand side of our grid. If it is, say, on the right-hand side of our grid, we do not want to check the square to the right of it, right? As those squares don't count. They will visually belong to the other side of our grid. The same goes for any squares on the left-hand side of our grid. If we check the square to the left, so square with the next 9, for example, it will be checking the square on the other side of the grid visually. So now, how do we tell our JavaScript that we don't want to check these squares in the same way? Let's do it by defining what is a left edge first. So it's left edge. If I, or technically the number from 0 to 99 that we are passing through, modulus width deeply equals 0, we know we are at the left edge. For example, let's take square of index 10. If 10 is divisible by the width, so 10, and leaves a remainder of 0, this deeply equals to 0. This means 10 is at the left edge. The same is true for 20, 30, 40, and so on. We do the same to check for is right edge. So if I modulus width deeply equals the width minus 1, we know we are at the right edge. For example, the square with index 19, when divisible by the width, so 10, leaves a remainder of 9. This is deeply equal to width minus 1, because that's 9. The same is true for square 29, 39, and so on. Let's just put these in parentheses for readability. Now that we have defined that, let's carry on. Okay, so if the square we are looping over, if that square contains the class of valid, so not a BOM in other words, we want to do the following. If I is bigger than 0 and is not indicated by the bang, is not at the left edge, and the squares to the left of it contain a BOM, we want to add 1 to the total. Just so we understand a bit more about what is happening here, let's visualize this a little bit first. So we are saying that if the square index is larger than 0, We are saying this as we do not want to be in this index right here, as we can't check any squares to the left of it as they do not exist and the code will break. So if the square index is bigger than 0 and is not at the left edge, okay, so if we are in square index 1, we are not at the left edge and this statement is true. So both statements are true and we can check the next statement, which is and. So and if the square to the left of my square, so down one index of my squares array, contains a bomb, we can execute the code to add 1 to the total. We only add 1 if all 3 of those statements are true. So if we whack a bomb here and the index of our square is 1, this statement is true and we add 1 to our total. Got it? Let's move on. We need to do this 7 more times as we mentioned before, so hopefully we'll get this by the end. So once again, if I is larger than 9 this time, as we want to check the square to the southwest of the one we are in right now, and this would mean the earliest we can start checking for the square would be in square 10 and is not at the right hand edge, and if the square in the index plus 1 minus the whole width contains a bomb, we can add 1 to the total. And again, so if we are in square index 10, we will be checking square of index 1 for if it has a bomb or not. This is true for even square index 12, 17, and so on. Before carrying on, let's see if this works first. So we are only checking 2 squares around us at this moment, but that's fine. Let's get the square we are checking and use setAttribute to add the total so far. We do so by passing through a name, so let's say data, and the total. Now let's use console log to see what exactly is happening in our browser. So I'm going to console log each square as it passes through my loop after going through the checks above. Let's save this file. Now let's go over to our browser and refresh. Great, you will now see that each square, along with having a unique ID and a class of bomb or valid set to it, will also have a data attribute with a total next to it. This total indicates if any given square has a bomb in the squares to the left of it or to the southwest of it. If both, it has a total of 2. Now that we can see how this works, let's carry on to account for all the squares. So if I is bigger than 10 and the square directly above it, so minus the whole width, contains a bomb, add 1 to the total. Note, we do not need to check if it's at a right edge or left edge here, as we are checking directly above the square. So we don't have to worry about checking if the square appears on the other side of the grid by mistake. Now, if I is bigger than 11 and is not at the left edge and the square directly to the left of it and 1 row up contains a class of bomb, add 1 to the total. And again, if I is now smaller than 98, so we are now focusing on the bottom rows towards the end of the grid, and is not at the right edge, and the square directly to the right of it contain a bomb, we add 1 to the total. Now, if I is smaller than 90 and not at the left edge, and the squares directly to the left and 1 whole width below contain a bomb, add 1 to the total. Also, if I is smaller than 88 and is not at the right edge, and the square directly to the right of it plus 1 row down contains a bomb, add 1 to the total. Finally, if I is smaller than 89 and the square directly below it contain a bomb, add 1 to the total. Okay, we are done. Now let's add an event listener to each square to see if this has worked. So, still in my createBoard function, and let's say right after we push the newly created squares into the squares array, let's add an event listener. So let's take the square and add the inbuilt JavaScript method of addEventListener to it. Now we need to pass through 2 things, the event, so in this case the click, and the function. So now, as I also want to be passing through a parameter into the function, I'm going to be using this syntax. So on click, I want to evoke a function I have called click and I'm yet to write, and into it, I want to pass the square. Now we have that set up, let's get to actually writing that click function, this time outside of the createBoard function. So let's scroll down. After the createBoard function, I'm going to define my click function and pass through the square as a parameter. So because this function is only being used inside the createBoard function for now, I know that I am passing through one parameter into it when it's being used. And it's the square I have decided to click. So if I do click a square, and if that particular square contains a class of bomb, let's simply alert us that this game is over for now. We are doing this just to see if everything is linked up and working really. So let's go ahead and save this file and head over to our browser. Now let's hit refresh. Luckily, we can see exactly where our bombs are for now, so finding one is not going to be a problem. Go ahead and click on a bomb. You should get an alert. And great, the event listener seems to be working. Let's carry on. Now, I don't really want an alert for now, as it might be a little bit annoying. I'm going to change this to a console log notification for now. You are free to change this to whatever kind of alert you want in your styling, whether it's a pop-up, scoreboard, or simple alert, that's up to you. So we have what happens when you click a bomb. Let's now focus on what happens when you click on a square with data attached to it, so a number. First, let's grab that number so we can use it in our JavaScript. Let's choose to call it total, as it's the total of all the bombs surrounding us. I'm going to grab the square we have clicked and using getAttribute, get the data attribute, so the number. Now, if the number is 0, we don't really want it showing up. We only care about the numbers 1 and above. So if total does not equal 0, we want to grab the square again and add a class of checked to it, so we know it's been checked. For now, let's flip over to our CSS file and add a color to the checked square so we can see exactly what is happening. I'm going to give my checked class a background color of red so we can see it clearly. I'm going to put it over the grid color, but below the bomb color for now. Okay, let's flip back to our JavaScript file. Now, once a square has been checked, we also want to display that total in the square at the same time. We do so by grabbing the square and using innerHTML to display the total. We then want to break this cycle, so we use return. Now, we've accounted for all the options apart from one so far, and that is if the square does not fall into the two categories above. The only square that fits this criteria is a square with no bomb in it and no data number higher than 0. For all of those squares, we simply want to give it a class that is checked. Let's do that here after the if-else statement. Now let's save this file and head over to our browser to check this has worked. Let's hit that refresh. And great, we can see a red square pop up as it is not close to any bombs, so must have a data number of 0. And these numbers, as they are close to bombs, show up with their data numbers. We also get a game over when we click on the orange square here in our console log. Now, what happens when we click on a square that already has a check class? Let's flip over to our JavaScript file to address this, as it will affect us when we do the recursion. We actually also want this to happen if there is a game over. So we don't want anything to happen if the game is over and we click a square. So if is game over, we return out of this function. If the square that is being clicked contains a class of checked, we simply break out of this using return. I'm actually going to add another statement here, as we want the same to happen if we click on a square that already has a flag. Using the 2 lines, this means or. So if the square contains a class of checked or a class of flag, we want to return. Let's scroll to the top of our file to declare is game over and assign it the boolean of false for now. Okay, great. Once that has been added, let's get back to our click function. The one thing we have not managed to do yet that is Minesweeper USP, shall we say, is the fact that if we click an empty square, we want it to fan out and fill up all the squares up to the numbers. I'm going to show you this here as it is hard to visualize when I say it, but when I show you, you will get what I mean. So, how do we do this? Well, recursion is the answer, and this is pretty cool. So, once I have clicked an empty square and marked it as checked to make it red, I need to start checking all my neighbouring empty squares as well. Let's write a function called checkSquare and pass through the square we have just clicked. I am also going to pass through one more thing, and that is the square's ID. We can technically do that in the next function as the ID is attached to the square we are passing through, but I'm going to do it here just to show you what passing two parameters looks like. So, check square and pass through the square and the square's ID. Let's call it current ID. I need to move this out. So what I'm saying here is I want to check to happen if the square does not contain a bomb, but also after the check for it does not equal 0. And then once it's checked, I want to add the class of checked. I mean, I guess technically I'd have kept it where it was, but I think this way is much neater. Now we have to do one more thing before writing our checkSquare function. I did say I want to pass down two parameters, but I have not yet defined the current ID. Let's do that now above anything else. As we simply want to get the ID of the square being passed down, we simply grab the square and use .id to get its ID. Okay, great, let's move on. Let's get to actually writing the checkSquare function. So as a recap, in this function, we are going to be checking the neighboring squares once a square is clicked. We are choosing to call the function checkSquare and pass through the square and the square's ID we chose to pass down as well. As I mentioned, we could have technically not passed through the current ID as it's attached to the square, but I wanted to show you that you can pass down two parameters, not just one. Now, the first thing we need to do when checking the neighboring squares is understand that we are going to be checking all 8 surrounding squares of any square we are checking. So, the logic in this is going to be very similar to the logic for when we add in numbers to surrounding squares. The first thing we need to do is check if the square we are checking is in the left edge or the right edge. So const is left edge equals current ID modulus width deeply equals 0. And const is right edge current ID modulus width deeply equals 9 or width minus 1. Now the next thing we want to do is check all the surrounding squares. I'm going to put this in a setTimeout as I want it to happen just that tiny bit after we click a square. This tiny bit is so important as we need it to happen after all the checks and the click function happen when it comes to recursion. So using the inbuilt method of setTimeout, I will write this and pass through 10 milliseconds as the time I want to pass before executing this block of code. Now, if the ID of square we have clicked is larger than 0 and it's not at the left edge, so this part should be familiar, we want to get the ID of the square that is directly to the left of it. So const new ID equals the squares array, and we pass through the current ID minus 1. I'm going to use parseInt to make sure that this is a number, not a string. Now that we have that square, we need to get its ID. Once we have the ID of that square to the left of the square we're currently in, let's grab it so we can work with it. So let's call this new square equals document getElement by ID as we want to find the element with a certain ID, and this is the new ID. Now that we have this square, we're going to do something cool. We are going to pass this new square back through the click function to be checked again. So if it passes, it continues to go through the loop again, and if it gets returned to the click function, the loop stops. As you can see here, we do not need to pass down the new ID. Why is this? This is because the ID is attached to the square we are passing down. So we are passing down the new square into the click function as a parameter. What the parameter is called is not important. JavaScript will know to take the first parameter. So let's get rid of this new ID here, as not only do we not need to pass it down, if we tried, it would just be ignored anyway by the click function. If this is confusing you, I've got a great video about functions. It's a quick explainer video, so please feel free to check it out if you would like some more clarification on what is happening. Right, so let's carry on with the recursion, but let's have a look at this with the help of a diagram first. Here we have our click function, and here we have our check square function. Now, what we wrote in our click function is that if a game is over, we return, so nothing happens. If the square we clicked has already been checked or has a flag on it, we also return, so nothing happens. If the square has a data number larger than 0, we want to add that data number to its innerHTML, so it shows up, and that's it. We mark it as checked and move on. We mark it as checked and move on. Now, if the square we clicked on is none of the above, so technically a square with a data number of 0, we want to mark it as checked and invoke the checkSquare function that will check all of its neighbors. So we check the first neighbor, second, third, fourth, fifth, sixth, and eighth neighbor. But what if we check the first neighbor? In that check, we also want to check that square's neighbor. So we go back to the click function and do all the checks again. If again the square is empty, we go back to the checkSquare function and so on until the loop is broken. Pretty cool, right? Recursion. Okay, let's get back to it. So once again, if current ID is bigger than 9 and is not at the right edge, I want to get the new ID of the square directly to the right, one whole row above it, so the southwest square. Then I want to get this actual square by using document getElementById and passing this new square into the click function to be checked again. Now, as I am writing this, I guess we could just be getting the new ID by grabbing the current ID and adding a 1 and a width to that, rather than going into the square array and grabbing the ID. That is also a quicker option. I will include this refactor option in my GitHub code if you want to have a look at that and what I mean. But let's stick to this way for now. So now if the current ID I've passed down is bigger than 10, remember for this one, we do not need to check if it's at a right edge or left edge, as we are simply checking the square above. So new ID equals the squares array, then the ID of the square directly above the one we are checking, and let's get that square's ID using .id. Now let's grab the actual element using getElementById and passing down the new ID and pass that square into our click function. Are we getting it yet? Let's talk through it one more time. So once again, I am saying if the current ID of the square I clicked, that was an empty square with a number of 0, and then passed down into the checkSquare function, is bigger than 11 and is not at the left-hand edge, I want to grab the new ID of the square directly one to the left of it and one row up, then use getElementById to grab that square so I can pass it through the click function. So hopefully now you understand what is happening here. We are using the same logic we did for adding numbers to the 8 surrounding squares around any square, whilst checking if the squares are valid when they are checked, but also adding an extra layer of things to be actioned. This is a great example of recursion happening and is super satisfactory when it all works as intended. I'm going to leave the next 4 for us to get on with, so see you in a bit. Okay, great. Once we have all 8 checks for the 8 surrounding squares to any square on our grid, let's save this file and see if it has worked in our browser. Let's hit the refresh button, And great. Just watch how satisfying it is to see all those squares appear and then stop at the numbers. And again, amazing. It's like watching one of those videos with a knife cutting into Play-Doh or something. It's really cool. I'm just checking everything works as it should. So the numbers are showing up, the correct totals are showing up, and a game over shows up in my console if I click an orange bomb square. And great. I'm pretty pleased as to where we've gotten to so far. So let's carry on. Now, the next thing I want to do is improve my game over. So let's get rid of this console log here. I want more to happen than just a notification, right? So let's get rid of that and write a function called game over. Once again, passing through the square we are working with. So down below the check squares function, let's write a function called game over and pass through a parameter meant for our square. I'm going to write a console log here saying boom, game over. So far, no change. The same thing will happen. Now, I also want to tell our JavaScript that the game is over, so I need to set the isGameOver variable to true. This is important for our click function, as it will return our click if the game is over, so that nothing can be actioned if a square is clicked. Now, I also want to show all the bomb locations if there's a game over. For this, I'm going to grab all of our squares and use the inbuilt method of for each. So for each square in our squares array, if the square contains a class of bomb, I want to get the square and in it, I want to write some text. In this case, it's a bomb emoticon. Okay, cool. Let's check if that has worked. So save the file, flip over to your browser. Now let's click on a square that we know has a bomb in it. And great, there are all our bombs as well as a notification in our console log. Let's move on. So how do we win in Minesweeper? Well, we need to flag all the bombs on our grid without hitting a bomb. We have an equal number of flags to bombs, so can only flag on the exact squares that the bombs are in order to win. Let's tackle this feature by first writing a function that will add a flag, then add a left-click event listener to all our squares in order to allow us to add flags on a control and left click of a square. So under the createBoard function, I want to write a function called addFlag like this. Again, I want to pass through the square. If the game is over, I want to return as I don't want anything to happen. If the squares I control left click has not already been checked, so does not contain a class of checked, indicated by this bang, and the flags I've placed are less than the bomb amount on the board, I want something to happen. First, however, let's declare the flags as a total of 0 at the top of our file. So scroll up and let flags equal 0. Now let's get back to writing our function. So if this is true, and also if the square does not contain a flag already, I want to add a class of flag to it. I also want to grab the square and its innerHTML. I want to add an emoticon of a flag to indicate a flag is there. I also want to add one to our flags variable using the increment operator. Else, if there is a flag already there, I want to remove the flag, so remove the class of flag, and also replace the text in my square. So instead of showing a flag emoticon, it simply displays nothing. We also need to take away a flag from the flags variable using the decrement operator. Great. Now that we have that, let's link it up to all of our squares. So in the createBoard function, under the normal click, let's add a control and left click to each square. Let's grab the square and add the inbuilt method of onContextMenu. Now we write function and pass through an E for event. We are passing through an event into the function. Now we need to use a prevent default to prevent the default action happening and add our add flag function here, passing through the square we have control left clicked. Okay, great. Let's save this file to check it out and see if it has worked. So hit refresh on our browser. And amazing, look at our little red flags go. If we press control and left click on our machines, we will see the little flags. So cool. Now we have one last thing to do, and that is tell our JavaScript what a win is. So once we are happy with this, let's go back to our project. Now, under the GameOver function, I'm going to write a check for win function. So let's scroll down. Okay, great. We need to decide what happens when we want to check for a win. So function check for win. This time we do not need to pass anything through, as I've decided that we are going to be checking over the entire grid each time we check for a win. So once again, let's use the for loop to loop over the length of our squares array, incremented by 1 each time. So if the square I am checking in my squares array contains a class of flag and, indicated by the double and here, and the same square contains a class of bomb, both of these statements are true and we can execute the following code. We increment the variable matches by 1. So let matches equal 0. Now, if the matches we are counting suddenly deeply equal the bomb amount, so what is that? That's 20. We want the following block of code to be executed. Console log you won. For now, I'm fine with that. Okay, now we have done this, let's decide where we want to check for a win. I guess it makes sense to check for a win after each time we place a flag, right? So let's go ahead and add flag here. So add flag function, let's put it there. So right under where we add a new flag to our flags variable, let's invoke the check for win function. Okay, cool. Let's save this file and see if it has worked. Hit refresh, and great, there is our flag. Let's go ahead and click all 20 bombs. So click, 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 click. Okay, and great. We get a notification on our console log telling us that we have in fact won. Amazing. Now let's do one very last thing, and that is set our isGameOver variable to true. And that's it. That is the functionality down. Well done for getting this far. Now, as always, I would love to see your finished game, how you've styled it, taken it to that next extra level. We do have a bomb amount that is a variable, so feel free to maybe level up, make new levels based on the bomb amount. Some people might want to add, like a timer. I think the original Minesweeper game does have a timer, so the user is constrained to a time limit while trying to find all the bombs. There are literally so many options. Please do share them with me on Twitter, Instagram, YouTube. I would absolutely love to see what you've done. If you have any questions, please do comment below. I'd be more than happy to help you with this game. If you want to see how I've styled it, please, again, do look at my GitHub. I put all my code there. The code is very much for you to take, make your own as well. So once again, thank you for watching.